Rail Safe Training welcomes you to industrial track inspections. Welcome everyone, and thank you for joining us. We're excited to have you here as we focus on one of the most critical aspects of rail safety and operational excellence: effective industrial track inspection practices. Today's session is presented by Lanny Dyvig, a respected industry expert with extensive experience in railroad operations, track safety standards, and compliance training. Lanny has dedicated his career to helping organizations improve safety, reduce risk, and maintain the highest standards across industrial rail systems. Throughout this presentation, Lanny will guide us through essential inspection procedures, key regulatory considerations, common problem areas, and practical strategies for maintaining safe and reliable industrial track infrastructure. Whether you're responsible for facility safety, track maintenance, compliance, or operational oversight, this session is designed to provide valuable insights you can apply directly in your organization. We encourage you to take notes and submit questions as we move through the presentation. Now, please join me in welcoming Lanny Dyvig.
Regular track inspections are more than a safety requirement. They're a critical component of operational continuity. By identifying and repairing defects early, you protect your crew from injury, prevent the devastating cost of derailments, and you keep your production on schedule. So basically, by identifying and repairing defects, again, you protect your crew from injury. Right? We have to really focus on that side of it when we're out there. Preventing the devastating costs of derailments keeps your production on schedule. So this proactive approach to minor wear, such as rail defects, tie decay, and drainage issues, things like that, those allow you to shift from reactive emergency repairs to planned maintenance. This foresight ensures major projects are integrated into your long-term capital planning, and scheduled during existing outages to minimize disruption. So when I'm out there, guys, and I know most of all of you have been railroads, you have some familiarity, obviously, with track maintenance because you've been out there in the operations. You've been out there running locomotives. You've been on the ground switching rail cars. And even if you don't have maintenance background, you still have that familiarity with it from being on it all day long, every day that you work. So the foresight, again, ensures major projects are integrated. We have to make sure that when we're out there, we're visiting with these folks about being proactive, right? Get it into the, if you don't have, I understand, right? We all, those of us that were in management had to manage a operating budget as well as a capital budget. We didn't always get what we wanted, right, in our capital budget. So we had to figure out how to manage it in our operating budget. Sometimes the expense was too much. So what we have to learn to do is try to get those into those long-term plans, the year plan, the 5-year plan, the 10-year plan. So talk to them about that. Safety and risk mitigation, catching failures like broken rails before they cause accidents, extending infrastructure life, and avoiding the premium costs of emergency fixes. We all know what that costs to call Holter out. It's I don't know what the number is anymore. It used to be something like $4,000 or $5,000 just to call them and get them on the road. That doesn't count when they get there and they start working. So it's very expensive when you have a derailment and you have to call side booms and caterpillars and Holters and RJ Cormans out to do your work. Operational reliability, eliminating unexpected delays to keep your supply chain moving. I think that's one thing that we fail to do or fail as a company. I say we, the companies that we are inspecting and the companies that we're doing industrial operations training and whatnot. What happens is the people think that if they keep on delaying it, they're saving money. But in the end, if they have a injury or an accident, they could be shut down for a day, a full day, for at least sometimes for the full shift, because people that are involved cannot work anymore, right? In some cases, you're taking them out of service, or in some cases, it was so dramatic and impactful that people can't work, right? Because somebody got hurt or died. So we have to remember we are eliminating unexpected delays by ensuring that we do a good job with our track inspections. So we're obviously going to take a look at rail defects with regard to cracks, worn rail heads, switch points damage, and frog defects. And I'll kind of get into a little bit of that later on. Track components, loose or bent fasteners, missing bolts, decaying ties, hard to throw switches, incorrectly placed derails and signage. Track geometry, we're looking at incorrect track gauge, distance between rails. We're looking at misalignment, uneven settlement, often indicated by standing water. So rotted ties, track that's just very, very out of line and undulating, if you will, right? We got ups and downs, and it looks like a roller coaster sometimes. So we have to make sure we take note of all that. The vegetation, I mean, it becomes a problem. Weeds growing in and around tracks, that's part of the track inspection. Clearances, they're always part of the track inspection where I'm constantly carrying my tape measure and measuring track clearances. So the 14-foot minimum from track center to track center, as well as our normal clearances. So your clearance from your nearest rail to the object that we're measuring, it has to be 6 feet or more, right? So anything 6 feet or less does not meet the standard. So we have to take note of those while we're doing track inspections. The FRA has a statutory authority to issue emergency orders if industrial or plant track conditions pose a possible death or injury. So typically, what we're referring to here is the FRA doesn't usually take part in these industry tracks, these private industry tracks, unless, like Charles noted when we were on a call here not too long ago, if it has something to do with hazardous material and dangerous chemicals, then they do have some added limits and regulations and the ability to come in more often. They have the ability to come in anytime they want. They just don't because of lack of probably funds, lack of the number of people they have to come in, things like that. They leave it up to the OSHA limits and the OSHA people that come in, right? Industry or plant railroads are excluded from compliance. The regulations should be used as a guide to ensure that their tracks are capable for carrying rail traffic. So even though they're not included and they don't necessarily have a written standard for class one 10-mile-an-hour track, they have to abide by class one 10-mile-an-hour track because the railroads that are coming in are not going to come in if they feel it is unsafe. So I think that's probably getting more and more prominent throughout the USA, at least. Everywhere I'm going, they're getting more input from the carriers that are coming in and out of their yard. They want to ensure that their track is to standards that are going to increase the safety of their employees and maintain as little risk as possible for those employees that are coming in, while at the same time we're protecting the industry employees as well. So it works out really well for both. Although there is some money, some operations money that needs to be included when they're doing their planning, because it is going to cost money to keep those tracks up to class one standards, 10-mile-an-hour standards. So the Federal Railroad Administration does not require regular inspections of industrial tracks, nor must the inspections be performed by a certified track inspector. I referred to that CSX letter that shared with Ken, he shared with Chuck, that implied that they were going to have to inspect their tracks monthly. But again, there's no written information that says they have to do that. Now, if the CSX comes to them and says, I'm not going to serve you unless you can show me that you're inspecting your track once a year or once a month, well, then that's a whole nother set of I guess, limits and processes that we have to evaluate, or they have to evaluate, which might involve people like us, or probably the folks that are being contracted to go in and work on their tracks at any given time, assuming they have somebody. Some don't even have anybody on a regular basis. So, however, with all that said, industrial tracks are used by servicing railroads, and those that are near bridges or that carry hazardous material must be maintained to class one standards. No ifs, ands, and buts about it. All right, so the recommendation from FRA, Is it all plant and industrial installations meet their FRA Class 1 standards? For further information, like we share with the customers, we can go to 49 CFR Part 213. I have a couple of those books, 213, 214. I think Dennis does too. Those are a bear cat to read through. I'm sure that the safety professionals on here, like Charles, will agree with that. It is terrible. I mean, absolutely terrible to find something in there. The beauty of technology now with the internet and chat GPT and stuff like that, I just go in there and type in what I want and I can find it right away. It's substantially easier than it ever was before. Hence the reason that most railroads will have a maintenance away book, just like they do air brake and train handling and general code, right? We're trying to simplify some of these rules and regulations, and in many, many cases, we're more stringent than the FRA is in a lot of standards because we want to ensure that we have no accidents and injuries. So when you're in doubt as to the condition of the track component or structure, a qualified track inspector should be consulted. They need to get a hold of their class 1 serving carrier or class 2 if in the case of short lines, and they have to have them evaluate what their track looks like. Okay, so everybody understands the structure of the railroad. You've all been around long enough, other than a few of the folks that are on here. Maybe Jeff hasn't walked railroad tracks before. But with that said, the focus is always right on it's concentrated on the load of the train, right? So right underneath the rails. So it's designed to kind of spread the pain, if you will, spread that load over that 56.5 inches, if you will, on the gauge. The ballast that we put on, the undergrade, the subgrade, the subballast, and the ballast, all are designed to kind of spread that load off laterally into the impact, so that the impact of that weight is all kind of spread towards the shoulder of the railroad. A lot of downward pressure, but it helps to kind of spread that load and I guess eliminates the possibility of just driving it straight into the ground. Will, of course, a good example of what happens when you lose that lateral support is when you're next to a river or something like that, and the side of your shoulder starts caving away, or we have drainage and we have water problems, and one side starts floating down and spreading out. So, very important to have that support on the shoulders as well as underneath the track to maintain that weight distribution, if you will. Um, just a few examples that we shared with in the webinar. Obviously, this is a very distinct and severe one. You know, you see a lot of them that aren't like this, but it gives you a pretty good reflection, if you will, on what happens inside this rail. If you'll notice, the darker streaks are the first stage of development, and the silver breaks are in the second stage. So kind of like if you equate it to rust, the darker ones probably had some failure there, defect failure early on, and they were there for a while. And then as the weight pounds on this rail all the time, we begin to see more additional stages of this break, and eventually it breaks out like it is now. So vertical split head failure. We have many different kinds of failures. The engine burn failure, right? A progressive fracture, right? So people think, oh, I'm spinning the wheels isn't that big of a deal. It depends how deep you go and the fact that you're diminishing the quality of that rail every time you take a piece of that rail out, whether it's a 16th of an inch or a 32nd of an inch, it begins to minimize the quality of that rail. And it creates a situation where you have this pounding effect, and this pounding effect will then progress into potential horizontal and vertical split heads, right? So the fact that the surface is not nice and smooth and it's riding across, that's what creates a lot of the problem. So when Dennis and I have been to a facility, I can't remember where it is, Dennis, maybe Georgia or whatever. So the wheel burns were literally so bad it almost made you go into shock, right? A couple of them. Some of them were bad, but not as bad as others. I'll show you a picture of a really bad one pretty quick for those of you that weren't on right here, right? We saw places like that at this
Mhm.
location, a couple that were maybe even worse than that. Now they still had it in the track because it was way at the end of the track, at the stub end of the track, and they didn't think it was hurting anything. But if they ever had to move a car across there, that would be a prime location that we're going to experience a potential break and then a potential derailment and then a potential injury. So we have to try to talk them into and I guess use enough of information and explain to them how critical it is when we have situations like this in our rail and what it does when the rail cars go over it and impact it, right? You're not only impacting the rail, but you're also impacting the wheels, and the wheels of the rail cars could break as well, or at least get damaged. So all of it impacts the whole process. It impacts the roadbed, it impacts the rail, it impacts the wheel wells or the wheels of the rail cars. So we have to really pursue and push when we see this. Are these crews, first of all, are they qualified? And second of all, are they using their sanders? And third, do they have the right machine? Are they trying to move too many cars with that small track mobile? Do they need to purchase a Hercules or an Atlas instead of a Titan? Is do they have the right machine, right? Basically, do they need a locomotive? Are they pushing that many cars? They need a small engine. So things that we need to visit about. This kind of a location is something that we definitely need to look at. Rail defects. Are we misaligned? Right? Do we have cracked angle bars? Do we have rail that's cracked that'll pop out and cause a derailment like this picture on the right? This misalignment covered up with dirt and sand. You probably wouldn't even be able to see it half the time of the year because water and sand and dirt are all over the top of it. So we have to figure out how do we talk these guys into putting some capital money into their budget or some more operating money in order to keep some of these locations, I guess, clear enough that you can even see if we have any problems with defects. So a lot to look at when you're out there. It isn't, I was a track inspector, right? So there's a lot of things that come natural to me when I look at them, but it isn't something that you guys that have been on the railroad are going to struggle to see. This is not a hard thing to see, right? You're going to see it easily, and we're going to bring attention to it. If you even look here on this right picture, look at that left tie. Look how the tie plates are digging into the tie. Now that indication is I got rotten ties, number one. The other indication is that that at one point in time, before they put that new tie underneath that joint there, we were spreading the gauge, right? The gauge was being spread. The weight of the load of the train was pushing it out farther. So we might have had 56 and a half inch gauge when you checked it, but when you saw that movement on those tie plates digging into the ties, laterally, then we also see that that gauge under load could be 58 inches, 57 and a half inches, whatever that width is on that plate on both sides. You got to take into consideration spread in both sides. So look at both sides. You could have another half inch or inch of wide gauge that you're not even aware of if you don't look and see what's happening under the load. Okay. So we have to make sure that we're inspecting well enough that we can see this. Now, again, if you look at the picture on the left, how am I going to see what's happening with the ties on the right? Right? I'm not. Right. So you can't even see it. And a lot of places that we go to, the cement plants, the grain plants, even the corn and the sand plants that we go to are covering are having issues with all this being covered up, or where it's blacktopped over or it's concreted over. So I mean, it's not even possible to look at what's going on when you got blacktop and concrete over. You can look at the wear of the rail. You can check the gauge, and many cases you're not going to see what's going on, especially under load, because it's not easy to see. So the best you can do is check the quality of the rail, check the gauge, and go from there.
Yeah, you might see you might see where the rail is pushing like against the cement,
Right.
but that's about all
Difficult.
you're gonna, yeah,
Difficult sometimes to see
right.
that because it's a lot of times the concrete and the blacktop aren't completely right up against the rail. So, but occasionally you can see that, but it is very difficult. So just keep that in mind. Rail joints. Again, I mentioned this a few minutes ago.
That's
So
correct. I'm
this,
with you.
if an angle bar, or joint bar is cracked or broken between the middle or two bolts, it must be replaced. There must be at least one bolt in each rail at the end of the joint. Right? So what I recommend is as a track inspector, our minimum was two bolts on both sides. So if we had a six bolt angle bar, we were okay if it just had four. But I do not encourage this particular side. We should probably think about changing it because I really believe that we need to at least have two bolts in there. If one breaks, we still have a relief. So if we see that there's a bolt out, 100% of the time I tell them they got to put that second bolt in, right? So I believe that both bolts need to be in because then that way I have backup if one of those bolts breaks. This angle bar is broke. It's already going to be a problem. It's not going to be holding much at all, right? You can already see how look at the bottom of the base of that rail. Look how the gap is in there. It's already a hanging tie. It's a hanging tie. The spikes aren't in. We do not have the stability that we're meant to have at this particular location, this joint, right? We have cracked angle bars, we have hanging ties, we probably have surface problems, and more than likely, with no spikes in there, we might even have a gauge problem. If not normal, under load, we have a gauge problem, right? So we have to make sure we encourage these guys that to change and correct these kind of things. At some point, if the conductor comes in there on the local and he sees this, he says, "I'm not coming in anymore." They could stop serving these customers until they get it fixed. That is their option, right? That's safety first. We're promoting that everywhere we go, right? So they have the option to say, I can't afford to go in there anymore. And then they'll have to carry on. They'll have to bring an emergency crew in there and make changes, which are much more expensive than being proactive. This is a terrible, terrible frog. Don't see a lot of these kind of frogs, but obviously, when you start seeing broke out frogs like this and they get farther back like this, it can, if the point was broke out too, it'd make it even worse, but it would direct it down the wrong track, right? So we have either self-guarded frogs, or we have the guardrails on the opposite rails of both of this particular frog, right? Both sides of the frog on the opposite rail has a guardrail. And that guardrail keeps flange that wheel from floating too far over. If they're going down the route to the right,
So you
then
have
that
to ram
guardrail
and then
keeps it
it
from
repeats like
floating over to the
this
left.
side, so
What happens is
slide
that
this way.
guardrail is only so long, right? So you get a frog that's broke out quite a distance like this, especially if the points broke out too. Now I don't have that support of that guardrail on the other side. The farther down the frog I get, and I have more ability now, not only to pound and break this frog, but the ability to be diverted to the wrong side, right? So we have to ensure that we focus on getting these frogs welded. Most of them nowadays, and they were before, they're look at the wheel burns, by the way, on the top of this thing. We're creating this situation ourselves by poor operation of the locomotive or the trackmobile. The magnesium frogs take hours and hours to repair. This one, I don't even know if it's repairable. I'm sure we could probably get a welder in there and work on it, but it would literally take a couple of days. You have to weld and grind and cool. Weld, grind, and cool, right? It takes forever. This magnesium, you can't just sit there and weld on it for ever and ever. I think you're probably all familiar with that, but it takes time, right? So this is a situation where they're going to have to give a lot of track time to the guy that's got to repair this frog. So again, delay to our traffic, right? Delay to our production because we weren't proactive. We didn't fix the situation. Look at the wear on the wing rails. Those rails that are coming out behind, you kind of see the left side has a little gunk up on it. It's not very shiny or anything, but the right side's real shiny. This frog is so damaged that the wing rails now are starting to wear down. You can see how well, I don't know, probably an 1/4 of an inch lower than they should be. They should all be level. You can see how they're wore down. This frog's probably beyond repair. A used frog, I think I was with a guy in Louisiana. He was checking out used frogs. I'm going to tell you guys that depending on where he purchased it and then whether it was new or used and what quality it was, he was saying the minimum was something like $12,000 to $14,000. That was for a used one. And that didn't include shipping and length of time to get it. It wasn't just like snap my fingers and put it on Amazon Prime. It was going to be a several months out to even get something like this. And a new one's even longer. 6 to 9 months out, I think, is what he was saying for something new. And I remember that in the engineering department. We had to plan way ahead. We had to order parts for all these projects and materials way out ahead, like a year or more than a year sometimes. So it takes time to get this product. So in rail defects, if a rail defect's discovered, obviously we have to promote reducing speed over that defect. You're all familiar with that. Continue operations over the defect if and only if it's safe to do so. I'll be honest with you. I've had trains before that I had to I let go across a particular defect at walking speed, and I watched them the whole time they were doing it. That's not the greatest thing to do, but sometimes you need to do that in the interest of getting the train out of the way so that you can make the repairs. Repair the defect, obviously. Take the track out of service if you can't get it repaired and you don't think it's safe to continue operation. I just came back from a industrial operations class in on-hands training. I had two switches that had at least 1/8 of an inch gap in it, probably pushing 1/4 inch. That I told them this needs to be adjusted ASAP, and they said, "Hey, I just had somebody out here adjusting it." Well, they did it wrong. They did it wrong. You need to get them back out here before that switch point, under load especially, gets split. Right? If you've ever noticed on a track, you're driving over rail cars are going over a track, just watch what happens to those switch points and stock rails as they're going over it, right? Watch the way that switch point floats sometimes, especially if it doesn't fit right. So very dangerous to leave a gap in a switch point when it starts approaching 1/4 inch. That's a problem. 1/8 of an inch is what I always push, and I always push them to get it fixed. Out on the main line, I didn't even like a 1/16 of an inch. I didn't want any gap on the main line. But if in doubt to the severity of any defect, always take the safest course of action, remove the track from service, and contact a professional track inspector. Okay. All right, gauge. Track gauge cannot be any tighter than 56.5 inches. And if the gauge, or 56, yeah, 56.5 inches, it's kind of
A lot of
56
these,
and a half inches. If the gauge is wider than 58 inches, derailments can occur. Specialized gauges are best suited for the task, but a tape measure or other measure may be used. I seriously
happen because
like
it's not
using a
sitting
tape
down
measure for
here.
gauge way better than a track
58
gauge.
right now.
Obviously, when we were out on gangs and we were putting in new rail, we used track gauges and we set the spikes so that we could get the gauge just perfect. But in this industry track world, a lot of this rail is mashed, old, and they'll have lips on the end of the rail. So you really need a tape measure so you can measure just underneath that lip to really see what the gauge really is. Because as that rail gets mashed, it tightens up, right? And obviously we don't want it any more than a 1/2 inch tight. But what happens is you will see little tiny strips of steel laying next to the rail right on the plates, especially in curves. As that rail gets mashed and as those wheels continue to put pressure on that, it'll just peel off that little piece of, call it 32nd piece or 16th piece of steel right on the very edge of the mash. But a tape measure is much easier to use. You can buy the kind that have the magnetized end, so it makes it a lot easier to check gauge when you're out there all by yourself. But 56.5, guys. Here's an example. Of class accepted track, class 1 track, class 2 and 3, class 4 and 5 with regard to the FRA. So if you'll see, class 1 is what we're talking about here. 4'8", that's your 56 inches, and then 4'10", that's your 58 inches. So that's the span, 56 to 58, with the prime being at 56.5. Now you'll see class 2 and class 3 tracks a little bit different, and of course accepted track. So the higher the speed, the less opportunity or less the minimal limits that you have, right? All right, so track inspection needed. Very obvious here, right? We don't see it this bad very often. I mean, I have, But this is a pretty bad situation. We got alignment, we got surface, we got bad ties, we got rock covering up the ties, we got obviously a lot of pumping in here. We have water drainage issues, no doubt. It's pumping, mud starting to come up through the ballast. Obviously, we have a problem, right? So it's very easy to see something that needs to be corrected. Even at 10 mile an hour, again, to Charles' point, our minimum requirements are 10 mile an hour. So we can have up to, I'll show you later on, but we can have up to 3 inches of cross elevation and still be legal class 1 10 mile an hour track. Do we want that? No, because we're going to create a situation where we get a lot of rock. Now we're not going to create some harmonic rock, because if we have max 10 mile an hour, we're not going to get into that harmonic rock, which is somewhere around 12 to 15,
With
somewhere
this
in
type
there.
of rail,
But
between
we
12 to
do have a
14 miles
problem
an
here, and
hour,
it is something that should be
be above
corrected.
10 in industry.
Ballast. It's difficult to maintain track in
It
your
gets worse and
track if
worse.
your ballast gets fouled or muddy and does not properly drain. This is a great prime example. Maintaining ditches and culverts helps to extend ballast life. Sometimes we'll go into these yards, they're trapped. They're a big old plant facility, machinery and stuff everywhere. There's nowhere to drain very easily. They've pinned themselves in many cases, or the drains that they do have are plugged up. So it's a struggle, and it really is a struggle. But this is a fine example of one of those struggles. We'll talk about it a little bit later, but we use a kind of a minimum standard of no more than 3 ties in a row. Rotten. You have to have at least 1 tie on each side of 3 bad ties, and you have to insure. So the key to this, or the caveat to this, is no more than 3 ties in a row bad, and both sides of them have to have good ties that are holding gauge. So there's a caveat there. You can have 3 ties in a row, but if you're not holding gauge in that spot, then you can't. Simple as that. It's easy to say I only had 3 ties in a row, but when you measure the gauge and it's not where you see the movement of the rail, even on those newer ties, if you're not holding gauge, and you got to lace a tie, what we call lace a tie in there. So you got to put another tie in there. In every case that I go to when I do a track inspection, even with 3 ties in a row, I highly recommend that they put a tie. Because in many cases, even if it doesn't show wide gauge when you're walking it, under load, you may get wide gauge, especially if the surface is bad as well. So highly recommend that this situation, you recommend lacing in a tie here in the middle, even if they can't afford to get all the ties changed. So another more conditions here with muddy, fouled and muddy ballast. Obviously, the one on the right is much easier to see. You can see that it's bumping. You can see that mud's coming up through the ballast. The one on the left is a little harder to see, right? You can kind of see the wet, muddy dirt in the middle of the track and over to the right. But look over to the left upper left-hand corner. Look how you see the ballast kind of flow. Little channel being made there from the water that's running through there, right? Another indication that we have water running in this situation, to the point of it's setting, right? It's setting right in this area, and it's going to cause that problem on the right before it's all said and done. So something we have to check for. Okay, cross-tie defects. So the cross-tie spacing for mainline railroad operation is approximately 19 to 19 and a half inches for wood ties and 24 inches for concrete ties. The number of ties is 3,250 wooden ties per mile, 2,640 concrete ties per mile in concrete, right? Example, I wanted to put on here, what is that? How many ties do I have at 19 and a half inches of wood? Wood ties are approximately 24 to 25 ties within a 39-foot section of rail. So keep in mind, you'll see here that FRA doesn't really have a standard that says no more than 3 in a row, but what they have is a minimum standard for any 39-foot section of rail, and not so many in a row that you're not holding gauge. So here's the rule. There's no rule permitting, I chat GPT this so that I could kind of get the wording that I wanted, right? So there's no rule permitting 3 consecutive bad ties. In fact, FRA regulations generally prohibit this. 49 CFR Part 213-109 requires a minimum number of effective ties per 39-foot segment based on track class, 8 to 12 for higher speeds. and having three failed ties in a row usually causes improper gauge support requiring immediate speed restrictions or repairs. So a tie is considered ineffective or bad if it cannot maintain gauge, hold spikes, or support the rail. Consecutive ties, while one or two bad ties might be allowed, depending on the surrounding ties, three or more in a row is generally seen as a serious defect leading to potential rail failure. Minimum standards. FRA demands that at least 8 of any 10 consecutive ties be effective on a class 3 to 5 track to hold tie plates. That's faster track, so doesn't really apply to us. But the last one, in some low-speed industrial sidings or very light-duty track, the rules might be less strict, but 3 in a row is still poor maintenance. So to my point, rule of thumb, we can have 3 in a row as long as we're holding gauge, but the reality is that we want to ensure that under load, we're also holding gauge. If you have a 39-foot, I think somewhere in here, I don't know where it is, FRA talks about you have to have at least 8 good ties in a 39-foot section of rail or something to that point. 1, 2, 3, 4, 5, 6. No, 5. I think it's 5 good ties. A minimum of 5 good ties in any 39-foot section of rail. Well, if you draw that out, and you put 3 in a row at every location, it really comes out to real close to that, 5 or 6 good ties. So just keep that in mind. Again, FRA is a little bit, what should I say, vague sometimes. They're staying at that 100,000 foot level so that there's no liability, I'm sure, on their part. Class 1 track with a maximum operating speed of 10 miles an hour. The Federal Railroad Administration track safety standards define the following requirements for cross levels. We'll talk a little bit about cross level and track service. Deviation from zero, which is tangent track, right? The deviation from zero cross level at any point on tangent track may not be more than 3 inches. That's a lot. Reverse elevation, cruise cross level elevation on curves where the outer rail is lower than the inner rail may not be more than 3 inches. So in a curve, what we're saying here is that we can have the outside rail, the high rail, be 3 inches lower than the inside rail and still be okay. That's how I guess lenient we are in 10 mile an hour class 1 track. Back to Charles's point, that's the minimum, guys. We sure don't want this to be what we're recommending, right? So if I see this, I'm recommending that they get somebody in there to get the track raised, even on tangent track. If it gets more than about 1.5 inches or 2 inches, I'm recommending that they get somebody in there to surface the track, because typically there's more problems than that. It's not just the cross elevation, it's the drainage, it's the bad ties, it's the gauge. So in yards, you're finding usually when you have this cross level issue, you're seeing this kind of stuff, right? You're seeing this kind of stuff. So we have more problems than just the elevation. But I wanted to throw this in so that you guys are more familiar, or at least somewhat familiar, with some of the limits that we are allowed. It's quite large, right? I mean, think about gauge at 58. We're talking about 1.5 inches wide. Something that you wouldn't even think about when you're out there riding track as a track inspector on class 1 or class 1, railroad. So anyway, obviously we want to make sure that if at any time you guys ever have the opportunity to give this class, the course is designed for individuals and companies that want to train their employees to evaluate the quality of the track structure and perform their duties safely. It contains information and instruction needed to work in a rail environment and perform duties without injury or damage to equipment. This course is designed to give a general, we should have that highlighted, general understanding of the component, structure, purpose, and condition of industrial tracks that have a maximum operating speed of 10 miles per hour or less. Many of the places we're going nowadays are doing 5 miles an hour. I even had a place at 8 miles an hour. You had 5 when they're switching cars and 8 when they're not switching cars, things like that. So again, this is a general understanding to the employees so they understand what they need to look for, what they need to report. And this is in a privately owned industrial tracks with a maximum speed of 10 miles per hour. The track inspection course will help you identify defective conditions that are or may become detrimental to the safety of the facility. our track inspection courses for industrial facility use and does not qualify you as an individual as a certified track inspector. For further information, see your federal regulations 49 CFR if you can find it. All right, so I always want to add this. I stole a couple slides from the webinar that I think Russell had on his or Andrew. But when I'm out there, even if I'm there for a track inspection, I'm checking the close clearances, the clearance issues, right? So I'm measuring there are no clearance issue locations, and I'm obviously recommending signs such as this to be put up ASAP and or paint them with very highlighted fluorescent high visibility paint. So just an example of this tracking clearance that we threw in here as well. You guys are all very familiar with that. Minimum 14 foot. That's that right mark there where it says clearance point. So center of track to center of track. 14 minimum foot is what RailSafe is suggesting. I will say that a lot of state and locally government agencies, if you look at any one state, it varies. It'll vary from typically the lowest one's about 8 or 13 to 13.6, sometimes 13s, 13.6s. Ken and I, for fun, I was going through it one day and showing him, and I sent him a link that showed each of these state agencies and how varied they were. But I think that we're moving towards even on the railroads of the more standard 14 foot. Now remember, that's 14 foot in your industry yards, depending on if you're a siding next to a main line or a main line tracks, right? We're upwards of 20 plus feet sometimes in those particular regulations. So remember, 14 feet track center to track center when you're out there measuring where they've painted them. Hopefully they've painted them, but if they haven't, then obviously they need to. And this is the kind of thing that we obviously recommend here. Paint them, high visibility, keep them painted, make them easy to see for the groundman. So inside and outside of both of the web of rail on both rails, and then a flexible cone like this is suggested in the middle of the track. You might have somebody say, well, I thought you said we weren't supposed to be walking or having tripping hazards. And I go, exactly, but you're not supposed to be walking in the middle of your track either, unless in the performance of your duties, which would be to hook up an angle cock or turn an angle cock on or hook up an air hose or something like that. So these are flexible and prevent as much tripping as normal, but it does give an indication for your locomotive operator and your trapmobile operator to help see where that spot is. This another example of a close clearance issue or a sign on the right. So another thing I always look at, I threw this slide in from the webinar too, from one of the other gentlemen's presentations, Andrew or Russell, but the blue flag is something I always check. Are we putting blue flags up when the people are working? And while I'm out there working, I'm taking interest in that because I also need to make sure that I'm protected. Well, how am I protecting myself? Well, obviously I'm protecting myself with typically a guy that's with me that is my flagman, right? And if he isn't, we'll line the switches away from the track that we're working on, and I'll ask them to put a lock on it. Sometimes I'm by myself, and I need to ensure where those guys are working and where they're at. So I never keep my back completely to wherever I'm working from. But you really, really need to make sure that you're providing yourself some protection with line switches locked away from you and potentially a red flag if they have them on the property, otherwise a blue flag. All right, so we want to make sure we're protected. Obviously, and share with them that this is the kind of percentages that we're looking at where people are not protecting themselves. All right, so the reality of the railroad safety is an extremely dangerous profession for the untrained worker. Good railroading practices and procedures ensure employee safety. Let's use them. It's up to us to ensure the safety of all our railroad employees.
Safety in industrial rail locations depends on continuous learning, attention to detail, and dedication to best practices. Thank you again for your time and engagement. We encourage you to continue building your knowledge through Rail Safe Training's educational programs and resources. Have a safe and successful day.